Welcome to another Discover Headless Tech interview from headlesscreator.com. I'm Marcelo Lewin, the Headless Creator, feeling all silly right now because of this silly little thing that just happened. Anyway, as always, get a hold of me right there, Marcelo at headlesscreator.com. Today is actually a really cool interview. We'll continue our conversation about structured content and knowledge graphs. We started this 2 weeks ago with Aaron Bradley. He's a senior structure content architect at TELUS. And we're going to continue that conversation. We're going to do a little recap of the interview from 2 weeks ago, and then we're going to continue that conversation. But before we get started, you know how this works. I'm going to tell you real quick why you need an account at headlesscreator.com. Go get your free account. You'll have access to this interview on demand after we're done. Plus, we'll do the editing and get rid of all that silliness that happened at the beginning. But you'll have access to this. Then you'll have access to all of the other episodes that come with it. On top of that, you'll have access basically to all of our content, which includes Content Modeling Weekly, Discover Headless Tech, this course itself, which is a mixture of interviews and also lots of tutorials. We have weekly tips courses. We just launched the Composable Commerce one. And we're actually about to launch another one next week. So stay tuned for that. Tons of Headless EMS courses, bootcamp courses. We're working on a new bootcamp course with Cloudinaries. That's going to be exciting as well. Lots of stuff. Get your free account at headlesscreator.com. You won't regret it. Okay, having said that, you know how this works. No more marketing. We're done with that. What I'm going to do now is I'm going to bring in Aaron, and I know he's going to make me look so much better and less silly than I did right now. So, Aaron, welcome.
Marcelo, I'm thrilled to be a part of the live broadcasting stream here. It's
gotta love live. I have my headphones. They're hidden, and they're plugged in here on this side. And I guess I must have unplugged it, and I'm like, what's going on? Everything was working. But you know what? Everything is great. Yeah. And it's Friday, so we can't complain. Yes. Anyway, hey, listen, welcome back. For those of you watching live, if you have any questions, put them in the chat. I'll ask Aaron. Thank you for doing this. I put you on the spot on part one because I had all of these questions in our conversation just ran long because it was such a good conversation, and I put you on the spot back then, and you agreed to do a part two. So thank you for doing that.
My pleasure to be here.
All right, so we're going to jump in. If you want to know more about Aaron, part one, we talked with him at the beginning and find out a little bit more about his background. But we're just going to start, and let's do a quick summary of a knowledge graph. What is a knowledge graph for those that missed part one?
Okay, we're going to be getting into this in a lot of depth, but my go-to definition is a knowledge graph, is a knowledge base of intelligently connected, machine-readable facts about things from one or more sources.
I see. So give us an example.
Sure. I'm going to start, and I'm going to use this as my touch point, the most accessible and notable example, the Google Knowledge Graph, right? So that's the panel you see on the right side of desktop results. If you search for kitten, you'll see a picture of a kitten, description of like cat, probably a bunch of links. That's Google's knowledge graph, and you'll see that at the top of the search results for mobile. And I can't help but mentioning this because it is really a critical part of Google's knowledge graph technology, is that we have it because of mobile, because it is not a good user experience to force users to chase down those facts on individual websites when you can collect them all in one place. So in a Google Knowledge Graph, to follow on the example to illustrate the definition, you have a bunch of facts about kittens that come from Wikipedia, may come from other sources, and there's a unifying, and we'll talk about it, and we'll just bracket it as an ontology, but there's an organizing principle behind that. That's the intelligent connection that allows Google to assemble all of these facts in a way that us mortals can understand on the other side of the screen.
Tell us about relationships, though, because that's a very important part of knowledge graphs, right? The relationship between these objects.
Correct, and that's the intelligently connected part. And it's often said in a knowledge graph that relationships, unlike in a relational database, ironically, are first-class citizens. That means, and I'll talk to the example I think I used last time with us, that Marcelo knows Aaron, and you have the two entities, Marcelo and Aaron, but that knowing is also a first-class citizen, that relationship. And you can imagine any number of relationships between people. Knows, is father of, is mother of, is employed by, right? And you can start
Likes,
to see
dislikes. I mean,
exactly, and tied to other entities. And you can start to say things like, oh, Aaron is employed by TELUS.
right.
And then you can start to put in rules and to understand things about what's expected. And this is, this is what we call a subject predicate object relationship. I'm the subject, Aaron is employed by TELUS. And there's different types of things I could be employed by, and others I can't, right? Aaron's not employed by sheet music, right? That makes no sense, but it is another entity, right? So that's what that organizing technology does in a knowledge graph, is it sets the boundaries of what sort of things you can say about what sort of things in your particular defined ecosystem.
Now, some people may be listening to this and go, well, how is that different than a content model? Because content models have entities, they have properties, attributes, and they have relationships too, right? References.
Sure.
So how is it different from that?
Yeah, I've been reflecting a lot on that. And I think the primary way is just what we indicated, that in a content model, structure is critical. And in fact, if you look at like kind of any number of definition of structured content, you'll see it talking, unsurprisingly per the name, about the organization and separation of content into its constituent parts. So it's about structure rather than meaning, or rather that structure is key for structured content, and semantics, meaning, is incrementally a value add, but doesn't exist at the fundamental level that it does in a knowledge graph. So that the relationship, and anyone that works in a headless CMS knows that you can have a content type that is then linked to another content type through a relationship, right?
Right.
But that relationship, in comparison to how that's defined in a knowledge graph, isn't a first-class citizen. It can be as plain as a JSON entry saying that an article can contain an image, right? An image object, but it doesn't say what else that an article can contain. It doesn't say whether it needs, to contain that, or it does, but not as a formal language. We'll talk more
Right.
about this. I think that that's
Well,
important.
and then contains itself is like an entity, right? That then you can say, show me other entities that contain something, let's say, where in a content model, you can't really do that because
Correct.
it's at the end of the day, it's a reference field, basically.
Correct. And so those of us that work in headless tech know that then you have the individual vendors that enable you to put rules on top of that model, or to use querying against that model, that make it more flexible and add that semantic. So, I work in Contempl, so I think as Contempl users know, you can have a relationship to another content type, and then limit which content types that links to, right? An article can contain an image, but it can't contain a home page, right? Whereas in a knowledge graph, that's standards-based knowledge. It's not a proprietary construction. Instead, there are standards that support that across ecosystems, and that's I think an important point in regard to knowledge graphs versus structured content, is that knowledge graphs, by their design and nature, allow you to de-silo content from different sources, right? Or de-silo data from different sources, whereas that's not a native competency of content, of structured content, or even of headless tech. If you have two different repositories that have two different sorts of content models, especially if they're, one is, let's say, Sanity and the other is Contempl, there is nothing in the world that's going to say, oh, I know how to interpret these and map these together, right? Or that there's a language in which I can do that. Whereas a knowledge graph there is. You can say, oh, I have this database here, I have this database here. There are standards that I can then decompose what's in those databases into discernible facts and combine them together in a virtual database.
Right, right. No, it totally makes sense. So, but you mentioned structured content. You really can't have a knowledge graph without structured content, right? I mean, you've got to have structured content. You can't have content that's page focused with design built into it. So, what is the
But you,
relationship between you?
you,
Go
you
ahead.
can't have a content knowledge graph without structured content. Correct. Well, kind
Right.
of, sort
Yeah, right. Yeah. So, what's the relationship between that structured content and a knowledge graph? Or how important is it to have structured content in your organization?
I'm going to harken back to what we talked about last time too, which is my definition of content, which I think helps
Yeah,
answer that
that
question,
was a good definition. Actually, yeah, it'd be good to
which is
repeat it.
data materialized as information for human consumption, right? So it's the materialization of that that makes it content. When it's not materialized, when it's sitting there in a relational database or a CMS, it's data, right? Because it hasn't been contextualized as information. That context is critical, which is why I kind of harped on that definition. The nature of that content changes or can change depending on the context in which it's presented, right? So fundamentally, and the whole point of kind of bringing that up in response to your question is that it's data, right? And in a content graph, then you use knowledge graph technology and standards saying, oh, I know the structure and meaning of things, and I can assemble them into payloads that I can then present as content. So in a content knowledge graph, kind of a made up term,
Hmm.
a knowledge graph that contains content, it treats content as a strategic data asset that you can then flexibly mix and match in terms of how you present that. And to your point about structured content, critically, yes, that the data and presentation layers are separate because you're dealing with content as a data and described asset rather than as a presentational asset.
So then, for those that have headless CMSs, how are knowledge graphs implemented through headless CMSs? So in other words, if you have multiple headless CMSs or multiple systems throughout the organization, what are some of the tools to implement a knowledge graph and tie everything together?
They are not, right? So you can't implement a knowledge graph in a headless CMS because they aren't designed that way any more than you can implement a knowledge graph in a relational database, let's say. What you can do is use knowledge graph technology to better control, well, a couple of things in a content knowledge graph. One, and I think looking at the questions that I think we're going to discuss, we'll talk more about formal classificatory semantics like
Hmm.
taxonomies, right? So it gives you mechanisms to precisely describe those content pieces, right? Thinking of structured content as being a bunch of individual parts. So you can use knowledge graph technology and standards to organize what you have available to you and to stitch it together in a presentation layer. And this includes, and I think this is critical, and this is where a content knowledge graph varies from simply structured content or content in a headless CMS, is that you can more readily combine that with content in multiple repositories. Recall my laconic knowledge graph definition that talks about taking data from one or more sources, and that's really kind of the killer capability of a knowledge graph. It's the ability to federate information from different sources. So in a typical headless CMS environment, you're still really dealing with a core repository, maybe connected to a DAM typically, right? But in a content knowledge graph, you can start to see, well, actually any sort of data that I can describe and connect becomes a possible input into that graph, both in terms of how I understand that material and in terms of what material is available for me to present to a user. Let's go back to the Google Knowledge Graph for a moment. If you were to type in something like GDP of Germany, right? You would get you get a piece of content which would almost certainly be a graph of gross domestic product for Germany over the course of several years, right? And so that's content. That's why Google Knowledge Graph is actually a really good go-to when we're talking about content knowledge graphs, because it's materialized for us to understand, right? So what Google did in milliseconds is stitch together information from different sources about that and combine it with the technology that then displays that for a user, and a user in different environments is also a good object lesson in Create Once, Publish Everywhere, right? To give you that information and to present it in a way that you can understand. So that information is coming from the World Bank and the UN, and is then organized by Google's ontologies and taxonomies. So it knows, for example, that I, as a user, saying GDP mean gross domestic product, and then it can look that up and then return that. So the semantics you start to see there, I think, are really important, right? That the meaning of the individual pieces that go into content become accessible in a knowledge graph in a way they don't in just a straightforward CMS implementation.
So in an enterprise, carrying the example of Google, inside an enterprise, doing something similar to what you said about Google, right? Is there a knowledge graph engine that ties all this together, starts building in the background all of these relationships that then you can then query and display on your site?
Sure, and I think the time has come to use the O word here, Marcelo. That being
Let's do
ontology,
it.
right?
Let's do it. Let's jump into that, because that
Um,
that's that in taxonomy we're going to have to jump in.
yeah. So let's start with ontology, because and all of this with the proviso, as I mentioned last time, there is not broad agreement about what a knowledge graph is. There is an entire cottage industry of defining the term knowledge graph. So your individual experience may vary both by who you're looking at and the actual work stream you have in mind. But an ontology is thought in most situations to be an integral part of knowledge graphs, or at least knowledge graph technology. And it's that mechanism that allows these different systems and to speak a common language. It describes the relationships between things and the shape and attributes that those individual things might have. And so in some ways you can see that's very similar to a content model, right? So an article is composed of these different attributes and
Right.
may be connected to these different content types. But it's far more formal, and it isn't restricted to anything. It can be, and that's why I use the language facts about thing. If it's can be modeled as, I can say, I can make a statement about it, then it can be included and accounted for in a knowledge graph by virtue of an ontology. Aaron knows Marcelo. Cool. In your ontology, you're going to have a person, because that's both Marcelo and Aaron. You're going to have knows, and that's also going to exist like you or I as its own identifier in a space that can be dereferenced. You can look up what knows mean. You can say the in knowledge graph.
And that's what you meant by first-class citizen. Knows would be
Exactly
first-class
right.
citizen, right?
Yeah, and
As opposed to a reference in a content model, it's not.
correct. And you would see that something, and the predicate would probably be named knows, and you would see that the range, right? The domain, who can know, and it has to be a person, right? And then the range of that would what can you who can you know in that sense, and it would be a person. And interestingly, and there's a good example, knows, but can't you know knowledge? Great, but you can. So Marcelo knows about headless tech, but that's a different predicate, because even though and it would have a slightly different name, probably knows about, right? And that has a different range. And it could also include persons, right? but it could include technology. And in fact, probably a relationship knows about could have any entity as its range. So you start to see, and I'm sorry, I'll try to keep it
Yes.
non-technical, but that's the way that information is organized in a knowledge graph. And that allows you, and the really important thing is that if you've got some other database where Marcelo has a relationship with Aaron, and some other database where Aaron knows somebody else, you can say these are both actually the same relationship, and I'm going to then equate the first one and the other one with knows, and I can then combine information from those two repositories. And if there's a bunch of people that Aaron knows in one and a bunch of people that Marcelo knows in another, those can be combined and create, you got it, a graph, right, of those relationships. And that's why it's a knowledge graph, right? And the word graph is important because just as one would kind of colloquially think of a graph, that's the way a knowledge graph is. It's connections between things.
It seems like context is very important because Marcelo knows Aaron is very different than Marcelo knows Headless CMS.
Absolutely.
So context is part of that ontology as well, I'm assuming.
Yeah. And again, getting back to the point where those relationships are first-class citizens.
Right, right. So now let's talk about taxonomies and explain taxonomies. How is that different than ontologies, and how do they affect a knowledge graph?
Yeah, so taxonomies, as I think most people know, are mechanisms for formally categorizing things, right? And typically concepts. So how they differ from ontologies is that they're flatter, right? That is to say, the relationships between things are more limited and may not even really exist at all, because there's also different levels of complexity with taxonomies and different names assigned to those. We have things like term lists, dictionaries, and then a slightly extended version of that called a thesaurus. So in a thesaurus, which is a standards-based taxonomy called the Simple Knowledge Organization System, or SKOS, you have predefined relationships between concepts. I'll just use two of them, the two major ones, because I think it's pretty accessible. Broader term and narrower term, right? So we were just talking, I just got a kitten. I'm very excited about that. So you can have a cat. A broader term is animal or pet. A narrower term is Siamese cat, right? So it allows you to say, oh, I'm going to classify these terms, and I'm going to describe some relationships between those terms, which is why most people think of taxonomies hierarchically, which is correct, in most situations, and that's a narrower term.